Hey engineers, this is Mr. Hernandez, and in this lesson we're going to be continuing our work with robotics. So we started off with our last assignment by learning about, what is a robot, what different parts do robots have, and in this week we're going to get started with virtual robotics. So it is just like robotics, except the robots aren't actually real. I know that's a crazy concept, so let's go ahead and take a look at what we're going to do. I'm going to start off with some kind of introduction, a lot of information, and then we'll get into what we're actually doing. I will note there are questions about a lot of these things in the document, so make sure you're paying attention. Make sure you're writing things down as you go as well. So without further ado, let's go ahead and jump into it. So let's start with sort of basics. So with our virtual robotics, we're going to be working mostly with programming our robot as opposed to building them. So what is programming? What does it mean to program a computer? Well, programming is just the way that we can tell computers what they need to do. So you can think about it like talking to the computer in a way that it can understand. And just like how we can communicate with different people in different languages, there's also programming languages. So a programming language is all of the rules that define what the symbols or commands mean to a computer. There are a lot of different types of programming languages, ranging from things like BASIC to C to Python to Java. But the one that we're going to be using is something called block programming. In block programming, all the commands that we can give to a computer, they're broken down into these blocks, and we program graphically by adding blocks together, as opposed to with text, like you can see on the side here. Now, the thing with programming is that computers always do exactly what you tell them to do. And that means you have to be really specific about the way that you say things. So in programming with text, you can see all of these parentheses, all of these different words and symbols, and all of those have to be exactly right or the computer doesn't understand. So with block-based programming, that all gets broken down to a block like this, and you don't have to worry about all the little symbols floating around. So from here, let's go ahead and look at the different types of blocks that we can use. This is sort of like filling in the library that we're going to be using. So the first type of block that we're going to use is called a hat block. And each block has a different shape that sort of tells you what it's going to do. So the shape of a hat block is it's got this rounded curve on top, and then it's got this little tab sticking out on the bottom. And that tells you that this is the starting point for a stack. You see, every block has these tabs that can interact and attach to other blocks. You can think of them kind of like the little bumps on the top of a Lego brick. That's what actually lets them stick together. Well, this one has a tab on the bottom, but this curve on top means nothing can attach there, and that just confirms this is always going to be the first block. Next block is the stack block. So the stack block is kind of the bread and butter here. Their shape is that they have a slot on the top and a tab on the bottom, and that allows every stack block to attach to every other stack block. If we're still thinking about Legos, these are the main bricks, the ones that are just rectangular, and you can use them for just about anything. So stack blocks are going to hold our main commands. So just about every real command that we want to give to the robot or to a computer is going to be some form of stack block. Move on to a slightly different type of block. This one is a Boolean block. So a Boolean block is not a command. It cannot stack. Instead, these have a hexagonal shape with no tabs or slots on them at all. And that's because of what they do. So a Boolean is something that can either be true or false with no in between at all. And what that is useful for is for things that are yes or no questions. So this Boolean here says left bumper pressed, which you can think of as has this button been pressed? It's either a yes or a no. There's no in between. And those can be used as an input for other blocks. See, this hex shape is going to fit into a hex-shaped block or a hex-shaped opening in a stack block. So this would make the program wait until this was true, which could be useful for making the robot only do something when a certain thing happens. So that's Boolean blocks, purely yes or no, true or false. Very similar is the reporter block. So these have an oval shape. They also have no tabs or slots, so they don't stack. Instead, they fit into other objects or into other blocks, just like the Boolean did. Now, the big difference is that the reporter block, this type of block, this one reports back numbers. So again, the Boolean is just going to be yes or no, but for things like distance, it doesn't make sense to just say yes. Instead, we want to be able to have all of those in betweens, all of those different numbers, and that's what the reporter block is for. All right, so let's go ahead to the last type of block, which is the C block or the loop block. And these are named C blocks because they are shaped like a C or like a mouth. These are interesting because they have a tab on the very top and a tab on the very bottom. But they also have a tab inside the C and a notch inside the C. So they're shaped that way because you can actually put stack blocks inside of them, and the loop block or the C block will make that stack repeat a certain number of times. So this first example here, this would make whatever stack blocks you put in here repeat 10 times. So if you want something to happen 10 times, this is what you would use. The second one shows how everything kind of interacts. So we've got a Boolean block here if left bumper is pressed, and then we have that inside the C block, and then there is a stack block inside here. So what this whole thing says is if it's true that you've pressed the bumper, then we're going to turn left. If it's not true, then nothing happens. So that's how the C block lets you decide when things happen or how much they happen. All right, so that's our last block type. Now let's look at some of the details. Certain blocks, or a lot of the blocks, have different features to them. So we're going to look at two of the features of these ordinary stack blocks. So these have this little down facing triangle. That's an arrow that will let you change a setting. So for example, if I were to click on this arrow here, I would be able to select from either turning left or turning right. They also have these little oval shaped openings. Those are inputs. So as we've seen, you can either put a reporter block into those, or you can just type a number into them. So that's what those are for. And again, those are how we're going to control what those different blocks do. So you've got a lot of options here for ways to control this. So now let's go ahead and take a look at the activity here. So in this document, you're going to use that first part of the video to fill in these questions here. So we're going to fill in the block type, the shape, and its function. And some of these are blanked out, so you're going to have to fill it in for yourself. Then you're going to answer some questions about these blocks here. So we've got two different drive forward blocks and two different turning blocks. You need to answer what the difference is. Last, you are going to go ahead and create your own program. Now, you guys don't know how to answer these yet because you haven't had a chance to use it yet. So let's go ahead and jump into VEXcode VR. You're going to find the link to that way down here. Now, when you open VEXcode VR, it's going to take you to this window right here. You can ignore the tutorial. We're going to go ahead and look at some of these options here. So we've got all of our blocks over here on the left side. We've got our kind of workspace right here. As soon as you open VEXcode VR, I want you guys to go up here to where there'll be a different name for you, but I want you to change that name to Castle Crashers. That's the project that we're going to be working on right now. Over here on the right side where it says Playground, I want you to click on that, click on this drop down menu right here on the top and switch it to Castle Crasher from wherever it is. This is our virtual robot. So we've got our code right here, and over here, this is the robot that's going to run that code. And this is its workspace. So I'll show you guys some more features of it in a moment, but first, let's try and answer those questions. So I'm going to clear this out, and I'm going to start with just the drive forward block. So this is the first one that we were looking at. I'm just going to attach it to the hat block. And then if I want to see what this does, I can just press play. So there's a start button way up here. So let's take a look at what the robot does. So I press play, the robot is going to follow that command and drive forward. Looks like it knocked down one of the castles. And it's still going and going. I think it's actually left our work area. So I'm going to stop. I'm going to reset the map. So that's what drive forward does. And now let's try the drive forward 4 block. So this one has a number here. Let's see what happens when I try this one. So I hope you guys saw what happened. I'm going to reset it just in case though. So for this one, the robot drove forward and then it stopped. I think it has something to do with the number right here. So just to double check, I'm going to change this value. I'm going to change this input from 200 to 800. I'm going to try this one again. So here the robot drives and it goes a little bit further, but it still stops. So that tells me that for drive forward, the robot's just going to drive forward forever. With drive forward for 800 or drive forward 4, that lets us put in a number and decide how far it's going to go, and then it will stop. And we have these drop down options here, so I can change from millimeters to inches for more control over how far it goes. You can also decide to drive forward or reverse. So we've got our 2 drive forward blocks. Hopefully that gives you enough information to answer this question here. Now let's take a look at the difference between these 2 blocks. So that's going to be turn right and turn to heading. So let's start with turn right for 90 degrees. Let's reset and take a look at the robot. So it turned right. That makes sense so far. And now let's try turn to heading. Reset first. And it looks like this one did pretty much the same thing. So turn right 90 degrees and turn to heading 90 degrees seem to be the same. But let's check out what happens if we run each program twice. So this one says turn right for 90 degrees, then turn right for 90 degrees. So I'm going to reset, start. So here, turns right, and then it turns right, and it's gone 180 degrees. Now let's try the same thing with the heading. Let's see. So this one turns right 90 degrees, and then it stops. In order to figure out what's happening, let's take a closer look at our simulator. So we've got some information about the robot up here. So I switched out the code to go back to the turn right code, and I wanted to pay attention to up here where it says rotation and heading. So I'm going to press play. So it turns right, and you can see both rotation and heading changed to 180 degrees. So the robot spun around 180 degrees, and the heading says 180. Now let's try the same thing with turn to heading. So here, when I press play, it rotates, and you can see, even though there's 2 blocks, it stops when the heading says 90 degrees. I want to try one last test here. I'm going to try and mix and match here. So first, it's going to say turn to heading 90 degrees, then turn right 90 degrees, then turn to heading 90 degrees again. Let's see what happens. So first, it turns to 90 degrees, then the turn right block sends it even further to the right, and then turn to heading 90 degrees sends it back. So what's happening here is that the robot has a heading. That's kind of like the direction that it's facing on a compass. The turn right block doesn't care about the heading at all. The turn right block is just going to take whatever direction you're facing and it's going to rotate you in whichever direction you put. So if it's facing this way and you say to rotate 90, it'll do this. If it's here and you say rotate 90, it'll do this. The heading, by contrast, it does care about what direction you're facing. So the whole circle that the robot can face in is split between 0, and it goes all the way around to 90, 180, 270, and then back to 0. So when you say turn to heading, it's always going to face to the same direction. No matter where the robot was starting, it's going to turn and face to the same direction. That's really useful when you know where you're trying to go. It's sort of like the difference between saying turn to face north and turn to the right. So no matter where you are, no matter where you're facing right now, north is the same direction. Whereas, if you're facing this way, turn right means go this way. If you're facing that way, turn right means face all the way around to the back. All right, so now on to the main event, what we're actually here for, the Castle Crashers tutorial. So this map right here is showing a set of castles. And in order to see that more properly, we can actually change the camera angle here. So right now we're in top-down mode, but we can also switch to the view of the robot. And what I want you guys to do for this assignment is write a program that will drive the robot around this whole field and knock down all of the parts of the castle. So that means that you're going to have to go to each of these in turn and knock them all down. So I want to show you guys just enough to get you started here. So obviously, based on how it's laid out, first thing that we're probably going to want to do is drive straight through to take this first set of towers out. So let's start with drive forward. I know we don't want to drive forward forever. I'm going to try going for drive forward for maybe 1200. So let's try this one. So it should drive through that first set of towers and knock them down. And now I can see that there is another tower over here to the left. So I am going to go turn to heading. And I am guessing a little bit here. I could probably be more precise if I drove forward just a little bit more. But I want to add on turn to heading. I'm going to try 280 degrees. That's going to be kind of off to the left, but not exactly. So let's reset and let's try this again. So it should drive forward still. That's going to try to turn. And now I can see it looks like it's going pretty close to the right direction. So every time I do this, I can add on another block. I can see how far it goes, and then I can experiment to see if it's going to work. So obviously that wasn't far enough, and I think this isn't far enough either. So I can change those out. So that's getting better, and from here, you would have to decide what your next target is. So are you going to turn all the way to the right and come and push all of these blocks? Are you going to turn to the left and come down here? Or even, are you going to ignore my instructions or ignore my starting point? And do you want to maybe instead, right at the beginning, you turn straight to the left and knock this one out first? It's totally up to you, but you do need to knock down all of the parts of the towers and keep the robot safely on board. I do want to show you something right now. So if we change to drive forward and change the camera angle to see what the robot actually does, you might be interested to see that there are some consequences to driving badly here. That's right, the robot can actually fall off the edge of the table. So be careful with that. Try not to let your robot crash. And remember, you at least in the virtual one, you can always reset it whenever you want to, and the robot won't break apart. So, once you are done writing this program, there's just 2 more parts to this assignment. I want a screenshot with the snipping tool, if you're on a Windows computer, of your code. So your code is all of the blocks that you needed to stack up in order to write that program. And I also want a screenshot of the state of the field once you're done. So that can be the top down, showing all the blocks moved out. It can also be the robot view. Just make sure if you do the robot view that I can actually see what happened. I don't want the robot view to be, of the robot crashing off the edge of the table. I want to be able to actually see that it did what it was supposed to do. All right, engineers, so that is this week's assignment. As always, if you have any questions, feel free to send me an email or jump into my office hours. I do hope that you guys enjoy the VEXcode VR because it can be a really good tool for us now when we can't get these robot kits out to all of you guys.